So in this unit, we're going to learn all about circles and the lines that cut circles into parts. Okay, so we're going to learn a lot about circles here. And so what I want you to do with this, this video is we're going to go through a lot of vocabulary, because if you don't know the vocabulary, you won't know where to put the numbers. And the math is fairly easy, but if you don't know where they go because you don't know the words, then you're going to run into problems. Okay, so we have to know this vocabulary, so I want you to write all these words in your notebook. I want you to look at each slide. I will explain each slide, but I want you to pause and write the definition and draw the picture for each one so that you have something to go back to. Okay, the first one is the definition of a circle. A circle is this black line. It is what they call a locus of points, or an infinite number of points that are equally distant from a center point. So there's an infinite number of points here, all distant from the middle, that create a solid line that we call a circle. A diameter is a segment that passes through the center of a circle, and it has endpoints on the circle. It does not continue, it stops at the circle. And then I included the formula or equation for diameter. A radius is a segment with one endpoint at the center and the other on the circle. Okay, so it's half a circle. And again, here's the formula for that, if you have to calculate it. The term concentric. Concentric circles are circles that have the same center point. So the yellow circle and the purple circle would line up on top of each other because you could put like a string or a pin in their center points and they line up. Circumference is the distance around the circle. It's the length of the black line. And then so I gave the formulas in several different ways, whether you have diameter or radius. You can calculate it depending on what you have. And then the area is the space inside a circle, the part you could color with a crayon, right? Okay, so here's some new ones. So this red line, that's called a chord. A chord is a segment with both endpoints on the circle. It does not go through the center. It's like a shortcut from edge to edge inside a circle. Something called a secant. Secant is a line that passes through the circle in two places. So it's an arrow that goes all the way through the circle and keeps going. So a chord stops at the boundaries. A secant will keep going. A tangent line. A tangent line shares one point with the circle. It looks like a line just resting on the surface. Okay? It's just a line that bumps into the circle one place. The place where it touches the shared point is called the point of tangency. If it's a tangent line, it's the point of tangency. Okay? It's the point where the bump happens, where the line bumps into the circle. So you might see tangent lines alone at a circle, or you might have what they call a common internal tangent. A common internal tangent is two circles that share a tangent line, but the tangent line cuts between them because it's internal, it's between, it's on the inside between the circles. A common external tangent is two circles that share a tangent, but the tangent does not shortcut between the two. It stays on the outside. So external on the outside, internal on the inside. Make sure you're pausing these and writing these definitions and drawing the pictures. So here's an exercise we're going to do. it would be beneficial if you drew all this. So maybe pause and draw this, and then we will go through it together. We're going to mix and match and put the letters on these lines that match the terms. So from G to H, right? From G to H, from here to here. Okay, notice it does not say line GH, it's talking about the distance GH. Okay, so be careful. GH is just that part right there. It's a segment that stops at the edges but does not go through the center. That is a chord. A chord stays inside and does not go through the center. M, point M. It's not the center, but it is where this line touches the circle. That line looks like a tangent line. So where the tangent line touches the circle is called the E, point of tangency. M to J. So M to J. Just that little piece right there. Half a circle. Half a circle is what we call a D, radius. Point J, number 4, point J. So just point J. Looks like it's in the middle of the circle. So we're going to call that A, the center. M to H. M all the way across through the center. M to H goes through the center. So it's a line that goes all the way across and stops and goes through the center. That is a C, a diameter. Okay. The final one is line GH, the whole thing. So line GH, the whole thing, and it goes through the walls and keeps going. Through the wall and keep going, that's F, that's a secant. Now we're going to calculate using our idea of radius, diameter, circumference, and area. So make sure you have those equations handy. Okay? So if we know the diameter, so in this first problem, they give us a diameter of 28 inches. Okay? So this whole thing is 28 all the way across. The first question is, what is the radius? What is half of this? Well, we know the radius, right? The radius is half the diameter. So in our case, that would be 14 inches. Circumference, the length of the black line all the way around, circumference. Circumference was wrote that wrong. Circumference was pi times diameter. So circumference we could write as 28 pi. Or you could put it into your calculator and you can round that number. Let's see what that is with it. So I get 87.96. Maybe inches. Area is pi times radius squared. Well, if my radius is 14, then my area is my 14 squared times pi. So I could say 196 pi. Or if I wanted the actual number, it would be 615.75, and this is inches squared. This is just inches, this is inches squared. Area is always squared. Okay? So let's see if you guys can fill out the rest of them. This one, the radius is 15. So you should get, after you've paused and calculated these, diameter would be 30. Circumference, you could say, 30 pi, or you could say 94.25 inches. Area, $225 pi. Oops, sorry, 225. I said 5 and wrote a 2. I'm sorry. 225 pi. Or you could say 706.86 inches squared. This one, the radius is 17. So your diameter is 34 inches. Circumference would be 34 pi inches, or 106.81 inches. Area would be 289 pi, or 907.92 inches squared. So make sure you can do those calculations.